Today's predicted to have a high of 73 and a low of... This just in, there's breaking news. A potential homicide is currently being investigated on the corner of Brown and Center Avenue. Let's take a closer look at the scenes. Tell me, Dr. Smith, what's being performed?
We needed to check the area for blood, but it seemed the killer did a thorough job in cleaning. To trace latent blood, we used a solution of fluorescein and hydrogen peroxide. When spraying with a fine mist, it does not require thickeners, which can make the DNA analysis more difficult. We sprayed the solution onto the carpet and shone a light-emitting diode over the area. The finer the mist, the more detail is shown. We were able to acquire a shoe print, and we are looking further into who the suspect is.
How does the actual reaction occur with the fluorescein hydrogen peroxide solution?
Catalyst to this compound is iron. Hemoglobin and red blood cells contain iron. So in a sense, the red blood cells act as a catalyst and help the reaction take place.
Thank you, Dr. Smith. Let's take a look at what a witness has to say. What did you observe?
Well, I was walking my dog and I noticed a car in the driveway. Winston had been to the vet a few days ago with an issue with his eye. They actually used a topical fluorescein to examine the eye to find a corneal ulcer, which is common in dogs, cats, and horses.
Not much, huh? Okay, this how old is the dog?
5, 6 years old.
Okay, 2 or 3 days ago, right? The eye tearing, is it?
Yeah.
No, I think it's like, no, I don't think it's 2. I think it's about 4 or 5 at least.
Huh?
4 or 5.
Yeah, 4 or 5 at least.
So the owner thought it was cataract, but actually...
No, I do not think it was cataract. I just made a I derived whether it was cataract or scratch,
okay.
I'm not sure.
Oh, okay.
Yeah.
So anyway, with the fluorescent stain, you can see the ulcer is green. And so it's the central side of the eye. So it's important.
You just heal by itself over time.
Yeah, but you need to wear e-collar and separate from the other dog.
Yeah, that's right.
For at least 1 month.
Okay.
Well, it seems like fluorescein has many uses. Let's see what else it can be used for. And feel better, Winston.
The corneal epithelium, instill fluorescein dye into the eye. Lightly wet a dye strip, draw down the lower lid, and dab the tip onto the conjunctiva of the lower lid. Have the patient blink to spread the dye out over the cornea. When the corneal surface is normal, the surface appears uniformly green. The green color becomes iridescent and easier to see when a cobalt blue filter is placed over the light. When there is a defect in the corneal surface, the green dye will adhere to it and stand out brilliantly. Here is an example of a corneal abrasion, and here is an example of a dendritic ulcer in herpes simplex keratitis.
And this is the fluorescein report. C20H12O5 is the chemical formula for fluorescein. It's an organic compound that can be prepared by heating the organic compound phthalic anhydride C6H4CO2O and resorcinol C6H6O with a zinc or sulfuric acid catalyst. It is found as a deep red powder after crystallization. It also can be found as yellow amorphous solid. When mixed with alkaline solutions, which have a pH higher than 7, it has a bright green fluorescence. This molecule was first synthesized by Adolf von Baeyer in 1871.
Warning: this reaction uses irritants and corrosive chemicals. This should be performed with gloves outside or in a fume hood. Greetings, fellow nerds. In this video, we're going to make fluorescein, a strongly fluorescent chemical. First, we get 166 milligrams of phthalic anhydride and add to it 220 milligrams of resorcinol. Then we add on top a few drops of sulfuric acid. Now we gently heat the mixture until it turns a dark red-brown. You may have to stir it around a bit to get it mixed. Keep heating it at around 200 degrees Celsius for about 5 minutes. What's happening is the phthalic anhydride and the resorcinol are reacting to form fluorescein. The sulfuric acid is acting as a catalyst for this reaction. When it's done, turn off the heating and let it cool down to room temperature before handling it. Here we are. Add in 10 milliliters of water. Fluorescein isn't very soluble in water, so we also add in some sodium hydroxide, about 300 milligrams, and shake. Now we have a solution of fluorescein. To test it, we put a few drops in water under ultraviolet light. And there it is. Let's try that again, but without the background sign. You might be asking why the concentrated solution doesn't also glow under ultraviolet light. That's because it's so concentrated that it absorbs and quenches its own fluorescence. A dilute solution doesn't do that. Let's do this one last time close up. Wow, this is better than a lava lamp. And that is fluorescein. Thanks for watching.
Learned how to prepare our fluorescein. Let's see how we can use the dye. Another medical use is an
In World War II, German aircrafts would be required to have fluorescein on board so that if they were to crash in the ocean, they would be easy to locate as the dye would be fluorescent in the water. This was mentioned in the previous video as seeing that when the fluorescein is in a dilute solution, it has more fluorescence than when it is concentrated.
Let's see how we can use the dye. Another medical use is an angiography and angiogram. Angiography is examining the blood vessels or lymph vessels, which contain large amounts of white blood cells, via an X-ray after introducing an opaque dye into the system. When introducing fluorescein into the vessels of the eye, it can help with diagnosing diseases like macular degeneration and diabetes. This form of angiography is special, however, as it does not require an X-ray, which can give off radiation. This process takes an alternative, as flashing a camera with a blue light can take a picture of the photoreceptor cells of the retina. This is able to be repeated multiple times with no potential harm to the patient. This form of angiogram, specifically with the use of fluorescein, was developed by Harold Novotny and David Alvis in 1959. Let's take a closer look at the process.
With angiography, a colored dye is injected into a vein in your arm or in your hand where it travels throughout the blood vessels in your body. As the dye passes through the eye's blood vessels, a special camera takes photographs of the retina or choroid blood vessels. These images allow your doctor to see if there are abnormal blood vessels in or under the retina.
Now let's watch the angiography in real time to show how fast and effective it truly is.
Possible uses of fluorescein in the future include removal of brain and skull-based tumors. This was first applied in 1948. However, it is still being tested for future uses in surgeries, where the fluorescence of the molecule can contribute to the tumor tissue being easier to see and in turn remove.
The DNA that was undamaged due to not using the thickener, we were able to analyze it. Fluorescent labeling of DNA allows for a rapid sorting of cells and particles, leading to rapid analysis. Fluorescein isothiocyanate and fluorescein succinimide ether can be used as reagents in this process. Lined up and tests are being compared to what we found
Who
on
would have thought that a molecule with a molar mass of 332.31 grams per mole and a vapor pressure of 4.1 times 10 to the negative 11th millimeters of mercury would have so many uses? C20H12O5 has definitely shown its worth in modern practices and has potential for the future. Tune in tomorrow for more on Chemer News.